Have you ever wondered if struct assignment guarantees that padding will be equal? If you're curious about how padding works in C structs, you're in the right place. Today, we're diving into the specifics of struct assignment and padding. I totally get it. It can be confusing when dealing with structs and padding. Many developers have faced similar questions, especially when trying to ensure data integrity in their applications. You're definitely not alone in this. Let's look at the specific question at hand. A user asked if assigning one struct variable to another guarantees that the padding between fields will be equal. They also want to know if they can use the memcmp function to check for equality of structs. To understand this, we need to consider how different compilers handle struct assignment. Most compilers use memcpy for assignment, which would typically preserve padding. However, the C standard does not explicitly guarantee this behavior. Stay with me. By the end of this video, you'll have a clear understanding of struct assignment and padding, plus a practical takeaway that you can apply in your coding. To address the user's question, we first need to understand how struct assignment works in C. When a struct is assigned to another, the behavior depends on the compiler's implementation. In most cases, compilers use the mempy function to copy the entire struct, including any padding. This means that if two structs are assigned, their padding will typically be equal. However, the C standard does not explicitly guarantee that padding will be equal across different implementations. This means that while it is common, it is not a strict requirement. If a compiler chooses to implement struct assignment by copying each member individually, it could lead to different padding in the assigned struct. This would make using memcmp unreliable for checking equality. In conclusion, while most compilers will maintain equal padding when using mempy, the user should not rely on this behavior for portability across different compilers. It's best to avoid using memcmp for struct equality checks. Fun fact, did you know that the C programming language was developed in the early 1970s? It's amazing how far we've come. Yet some of these fundamental questions still puzzle developers today. Now let's look at the answers provided by other users. This user points out that you cannot rely on using memcmp to check for equality of structs. They explain that the padding area between struct members is not guaranteed to have a specific value. Therefore, when assigning one struct to another, copying the padding content is not required. Here's a tip. Always check your compiler's documentation regarding struct assignment and padding. This can save you from unexpected behavior in your code. And there you have it. Understanding struct assignment and padding can be tricky, but now you have the knowledge to navigate it confidently. If you found this video helpful, please subscribe for more insights and tips.